Alright, so now we're going to draw the Lewis dot structure of sulfate. So the sulfate ion, you need to know, SO4 2 minus. So if I'm going to draw that structure, we need to be able to follow the process. I put the sulfur in the middle, 4 oxygens around it. Then I have to think about how to draw the structure. With a -2 charge, that means I'm going to give an extra electron to 2 of the oxygen atoms. So I'm just going to say I'm going to give it to the one on the right and the one on the left. Randomly, you can pick any 2 you want to. If you give an oxygen an extra electron, that means instead of having 6 electrons, it's going to have 7. If it has 7 electrons around this oxygen, that means he only needs to make 1 bond to the sulfur. So 1, 2, 3, 4, 5, 6. The 7th electron is going to form a bond to sulfur. So that oxygen is happy. I'm going to do the same thing on the other side. 1, 2, 3, 4, 5, 6. Make the bond. So those 2 oxygens, by giving them an extra electron, they don't have to make as many bonds as normal. But this oxygen, he doesn't have a negative charge. He has to be normal. So that means he's going to have to make a double bond to get to his octet. Double bond with 2 lone pairs. That's a normal oxygen atom. And then another double bond with 2 lone pairs on the top. So that is a Lewis dot structure of the sulfate ion. However, covered in the last video, sometimes there's more than one structure that could be drawn. So if I just asked for the Lewis dot structure, you got an answer and that's good. But if I ask you for all resonance forms, then you have to think of how many different ways could you have drawn that structure and still meet the octet of all the atoms. So I'm going to summarize. I could have drawn to that one, and actually I should put my brackets and the 2 negative charge on the outside. And then I put an arrow with double head. That's just a symbol that's used between resonance forms. But I could have done the sulfur with the double bonds to the outside and a single bond to each oxygen. Or I could have done a double bond to the left and a double bond to the top and a single bond down and a single bond to the right. And I can keep going. I believe that I should be able to draw 6 different forms with this. Let's see, up and right. So that's 5. 1 more. Do double bond down, double bond left, single bond up, single bond right. So all of those are unique resonance structures. They're all equivalent to each other. Any one of them could be the right structure if I put in all the charges in lone pairs. But those are the possible structures you can come up with. So then I might say, okay, from those, can you draw the average resonance form? So what would the average resonance form look like? I'm going to put that here. I didn't plan my board very well. Sulfur in the middle. And then for each oxygen atom, like let's look at the one to the left. It's got a single bond in this one, a double, a single, and a double. So if I count it up in the 6 forms that I drew, it has a single bond in 3 of the forms and a double bond in 3 of the forms. So that's half and half. So that means that from the sulfur to the oxygen on the left, it's going to have a full single bond, a part of a double bond going to that oxygen. And I can calculate the bond order. The bond order, which we'll call it BO, equals, and all the oxygens are going to be equivalent to each other. Hopefully you can see that in your structures. There are a total of 6 bonds being shared here between 4 oxygen atoms. So my bond order is going to be 6 bonds over 4 oxygens, which if you divide that is 1.5. So the bond order is going to be 1.5 between the sulfur and all the oxygens. Okay, so I can draw the same way for all the oxygen atoms, a solid line and a dotted line to each oxygen. Then I think about charges. Sulfur is neutral in every structure I drew. Always neutral. If you count up, sulfur always has 6 electrons around it. We didn't change that in any of the structures. So the sulfur never has a charge. The oxygen atoms, if I label this properly in this structure, I'd have a negative here and a negative here. Oh, excuse me, a negative on the singles. Over here I'd have negatives on these two. Over here I'd have negatives on these two. It's always the single bonded oxygens that have negatives. You would find out that each oxygen has negative half the time. So the structure, it should be negative 1/2, negative 1/2, negative 1/2, negative 1/2 is the charge on all the oxygens. They're all going to be sharing the charge equally. So that gives me two negative charges being shared by 4 oxygens is going to be negative 1/2 each. Okay, so that is my average form. What I should learn from that is that the bonding from sulfur to any of the 4 oxygens is always equivalent. It's halfway between a single bond and a double bond. The charge on each oxygen is always equivalent. It's about a negative 1/2 charge on each oxygen. It does add up to give me the overall charge of the ion of -2 that I would be looking for. Okay, so that is SO4 2-. Now, let's move into a related molecule. So I'm going to erase a lot of this stuff. What if I had the hydrogen sulfate ion? So now I'm basically changing my structure, and I'll start over. HSO4, with sulfates -2. If I put a hydrogen on it, that's going to add 1, so it goes from -2 to -1. So it's HSO4-. What will that look like? Well, sulfate and hydrogen sulfate are related to each other. We really shouldn't have to start over if we can think about how they're related. I'm going to essentially draw the sulfate ion. Okay, that's at least the template for the sulfate ion. And the hydrogen is going to attach on to one of the oxygens where I would normally put a negative charge. I'm going to attach the hydrogen onto there. So I can do it on the top or the bottom, but I'm going to put it right there. If that oxygen makes a bond to sulfur and a bond to hydrogen, he's now satisfied. He doesn't need a negative charge anymore. Neither do the 2 oxygens that have double bonds, because again, they got their 2 bonds, so they don't need it. So now in this structure, there's only 1 oxygen that's still missing its octet, but if I give him a negative charge, that means I'm giving him an extra electron. So he has his 3 lone pairs. The ones with double bonds have 2 lone pairs. And then the one here, anytime oxygen has 2 bonds, it should have 2 lone pairs. So that now is a reasonable structure for the hydrogen sulfate ion. Now, that's one structure. How many resonance forms could we have? Now, a minute ago, when we did sulfate, we rotated the double bonds around all 4 oxygen atoms because they all were involved in sharing the double bonds some of the time. That won't be true with this ion because one of the oxygens is not going to want to have any part in the double bond. If you look at the structure, one of the oxygens, instead of making a double bond, it's making 2 single bonds. So this oxygen right here is no longer going to be part of the sharing of those double bonds. Essentially, I'm going to share the double bonds between these 3, and the ways I could do it, so I'm just going to bracket off. Instead of sharing it double bonds across like that, I could do a double bond up, a double bond left, single bond right, that's where my negative would be, and then the OH. That's a possible structure. It's equivalent to that one. Or I could do the double bond up and double bond to the right, which then puts the negative on the one on the left. And give me that structure. Now those are the only three permutations that I could have that kind of meet all the requirements that we're shooting for, because the oxygen on the bottom wants no part in the double bond. Okay, so now if I want to draw the average, so that's my three resonance forms. If I need to draw the average, I'll draw it over here, the average resonance form. The sulfur in the middle. The one going down where I put my hydrogen, it's not going to change at all. It's consistent in all the structures. But the other three are the ones, these three are all sharing the double bonds. So for all of those, I'll put the single bond with the dash, the single bond with the dash, and the single bond with the dash. Those three options are involved in the resonating electrons moving around. What about the charge? Well, how much charge is there? There's only one negative charge in each structure. It's a -1 charge. It's being shared by three oxygens. The fourth one is not part of it. So if I take a -1 charge and share it amongst three oxygens, that means that each one's going to have a -1/3 charge. So -1/3, -1/3, -1/3. That's the only charge present in the structure. And then what's the bond order? How much bonding is going on right there? Okay? Well, I specifically look at these three locations. There's 2, 1, 2. There's 5 bonds in that region being shared by three oxygens. So it's going to be 5 bonds over 3 oxygens. The bond order is going to be 1.67. So it's like 1.23 bond, or excuse me, 1 2/3 bonds between the sulfur and each oxygen. Okay, but again, all three of these oxygens are equivalent to each other in how they're bonded to the sulfur and how much charge each one carries. So that would be my average resonance form that I'm looking for. Okay. Finally, we'll draw sulfuric acid. Now again, I shouldn't really have to start over on my structure because it's going to be very similar to the ones we've drawn so far. So sulfuric acid, H2SO4. Again, starting from my template. I know sulfate, again, you have to work your way to this, but sulfate always has 2 double bonded oxygens and 2 single bonded oxygens. Normally the single bonded oxygens will have my negative charges. If I'm going to put hydrogens on, they're going to go where the negatives would have been. So this time I'm putting 2 hydrogens on. So I'm going to put one here and put one here. And this time there's no charge on the molecule. Well, if I look at my structure, I don't need any more electrons. All the atoms are satisfied without any electrons. If I just fill in my lone pairs, every time oxygen has 2 bonds, it'll always have 2 lone pairs. So in all my oxygen atoms, they have 2 bonds, 2 lone pairs. Everybody's satisfied. That is a Lewis dot structure. Do I have any resonance forms? Well, my 2 oxygens that have hydrogens on them, if it's making 2 single bonds, it's going to be happy with that. It's not, those oxygens don't really want to change or be involved in any resonance. The 2 oxygens that don't have double bonds, don't have hydrogens on them, they're both double bonded, so there's really no moving back and forth because they're the same. So for sulfuric acid, there is only one structure. With sulfate, we had 6 structures. With hydrogen sulfate, we had 3 structures. And finally, with sulfuric acid, there's just 1. The more hydrogens you put on there, it kind of messes up all the permutations that you can draw. So we get fewer and fewer structures as we go. Okay, that's pretty much it. You can do this type of thing with phosphate going to phosphoric acid, carbonate going to carbonic acid. All of those groups would follow a similar trend to what we just did with sulfate, to hydrogen sulfate, to sulfuric acid. Okay, that's it.